All right. So yesterday, you should remember that we began talking about if-then statements. That was the key idea that we did. And we went through about half of the notes that we need to learn about if-then statements yesterday. We figured out that a conditional statement was something that was true under certain conditions. You typically called the if part the hypothesis and the then part the conclusion. And pretty much we learned that and we did a bunch of examples of that, and that's pretty much what was up yesterday. So today we are going to expand things a little bit from there. And it turns out that whenever we deal with conditional statements, one thing that we care about is whether it's true or false, what we call the truth value of the statement. Because obviously what you hope is that things that you say or things that you hear are true. And you want to have some clue of how you could tell whether they are or not. So that's what we're going to end up learning about today. It turns out that in order for a conditional statement to be true, what has to happen is every time the hypothesis is true, the conclusion also has to be true. If the if part happens, the then part's got to happen too. That's the whole idea of what makes a conditional statement true. Yesterday, I repeatedly used the example of if you get 93%, then you'll get an A. And the whole idea there is that probably is a true statement because according to the Garrigan grading scale, if you do get 93%, I'm supposed to give you an A, or at least an A minus. And so, yeah, if the if part happens, there's a pretty good chance the then part's going to happen too. Now, on the other hand, if I tried to turn that around and I said, if you get an A, then you get 93%, that might not be true. Because maybe I gave you extra credit. Or maybe there were other things that factored into the grade besides a straight percentage. There's a lot of other things that could conceivably happen, and that might end up changing things. So we're going to look at another quick example here. I have, if there's a teacher in service, then we get out early, and I'm pretty sure that is a true statement. Because I'm pretty sure whenever there's a teacher in service, you do get out early. That's the only possible exception to that would be like when we had in service before the year even started and you weren't in school to begin with. But, like, I think it's actually next Wednesday, not tomorrow, but the week after that, we will have a teacher in service and you will indeed get out early. Last week, there was a teacher in service on game day and you got out early for that. Yeah. Oh, I always love those questions. Yeah. Never mind. Okay. Again, though, if I tried to turn that around and I said if we get out early, then there's a teacher in service, that's not necessarily going to be true. It could be, but it doesn't have to be, because it could be like a holiday or a snow day or some other reason that you got out early besides there being teacher in service. Okay. And that actually leads into what we're going to talk about mostly today, which is how you can change around if-then sentences, how you can change around conditionals and come up with different statements that sometimes are true and sometimes aren't. Okay? The things we're going to learn about, which it actually tells you in that picture, are what are called the converse, the inverse, and the contrapositive. And it turns out none of those is hard, but they all have kind of weird names, and we need to figure out what's what as we go through those. Okay? So the first one is what we call the converse. And Converse in math has nothing to do with shoes, but it was an appropriate picture to put on there, so that's why we dug it out. You remember yesterday I told you that an arrow just means if the first thing, then the second. So we're basically saying the converse of if A, then B is if B, then A. Basically, this is telling you you go backwards. You flip around the if part and the then part. You flip around the hypothesis and the conclusion. if you were paying attention closely, all the examples I told you a minute ago of things that weren't necessarily true, what I actually did was the converse. I flipped them around, and that made things that weren't quite what we were expecting to have happen. But yeah, you flip it around and you go backwards. That's the converse. So I've got a couple of questions for you. It says, find the converse of these things. And I started off with, if today is Monday, then tomorrow is Tuesday. Who can tell me the converse of that? Caleb. I would actually accept that. He said, if today is Tuesday, then yesterday is Monday. What were you going to tell me, Sam? Which is, if you literally use the words that are in there, you'd leave it as tomorrow and today, but it's fine. You made more sense of it, is basically what you did, and that's okay. The point is, we've got to start with Tuesday and end with Monday, and that is what you would have. So how about the second one there? Two angles of a triangle have the same measure, then two sides of a triangle have the same measure. What would be the converse of that? Go back to Sam. Go ahead. Yeah, the sides are the first part and the angles would be the second part. If two sides have the same measure, then two angles have the same measure. Again, you just flip it around. That's all you do with those. So here's another couple of things. Find the converse of, if there's mass, then classes are short. What would be the converse of that? Eli, what do you think on that one?
Classes are short.
And that's exactly right. If classes are short, then there's mass. That's exactly what it would end up being. The last one, it says all squares are rectangles, which if you think about it is basically saying, like, if something's a square, then it's a rectangle, is pretty much what we'd have. So what would the converse of that be? Go right back there, yeah. Say it again. He said all rectangles are squares, and that's fine. Or, like, if it's a rectangle, then it's a square. And the point of those two is to show you that when you do the converse, it isn't necessarily true. Because there are a lot of rectangles that aren't square. Like every poster on the back wall is a rectangle, but it's not exactly the same on all the different sides, so they're not truly square. It's also true that if you have short classes, it's not necessarily because of mass. There's other things that can shorten up classes as well. And so the converse could be true, but it doesn't have to be. That's really basically what it's saying there. And so you want to remember, converse goes backwards, flip it around, but it doesn't necessarily have to be true. That makes sense to everybody. So I told you there are three things we were going to go through. Converse was the first of those. To get into the second, I need to introduce you to a symbol you're going to see in your book periodically, which looks like it belongs in Spanish class. And it is just a little squiggle, basically. It's also what was on top of the congruent symbol when you were noticing that before. And all it means when it's by itself is not. Now, we're going to find out much later in the year. It can also mean some other stuff, but in this context, it means not something. So if you see a little squiggle, yeah, it just means like not or the opposite of is what we're saying. And that leads into the second of the three things that we can have, which is the inverse. Tells you the inverse of if A, then B is if not A, then not B. Which basically just means that I put not in both parts. I make both halves of it negative, but I keep the order the same. So converse is backwards, inverse is negative. That's really the difference between those two. And we'll watch the pencils fly for a minute, and then we'll go through a couple of examples of those. So who can tell me, what would you do for the inverse of if today is Monday, then tomorrow is Tuesday? What would be the inverse of that? Go back to Caleb. And he's exactly right. If today is not Monday, then tomorrow is not Tuesday. And of course, you could say like isn't instead of is not. That would be the same thing. As long as you get the basic meaning of it across, how exactly you write it is fine. And typically, like if I'm writing out my answer key, I abbreviate a lot. There's nothing wrong with that. How about the second one? If two angles of a triangle have the same measure, then two sides have the same measure. Go for it. Yeah, if the angles do not have the same measure, then the sides don't have the same measure. That's what you'd end up putting. Sometimes I've had people that will say something like if two angles have different measure, then the sides have different measure, which is just a different way of saying the exact same thing. The point is not the angles, not the sides. And you keep that order on it. So how about this one? If there's mass, then classes are short. What would be the inverse of that? Yeah. If there's no mass, then the classes aren't short. Absolutely. And how about all squares are rectangles? This one you may find a little bit harder to put in words, but we'll see if we can come up with that one. Yeah, Jacob. More or less. I'm going to actually rephrase this and see if you can do the inverse of what I rephrased. Again, if I put this in if-then form the way it looks right now, I just say like, if something is a square, then it's a rectangle. And so what would be the inverse of it when I write it in if-then form? Then I'll get back to what Jacob said here in a second. Well, I think the inverse would be if it's not a square, then it's not a rectangle. That makes sense? Okay. Which is slightly different from what you said because you still were basically starting with squares, but then you were saying that it's not a rectangle necessarily. And you do need to make like both halves of it not, which is sort of the weird thing. So the last two that we just went through are things that again are showing you that this is not necessarily going to be something that's true. Because when I say if it's not a square, then it's not a rectangle, maybe not a square is a rectangle to begin with. Maybe I am looking at that map that's right above Sam's head back there. That's not a square, but it is a rectangle. Same thing on if I said if classes are short, if there's not mass, then classes are not short. Well, we had back on the day before Labor Day, we had short classes because it was a holiday coming up. And, so we did have not mass, but classes were in fact short. Again, so far, converse you go backwards, inverse is negative, neither of those is necessarily true. Okay? The third of the ways that you can screw up an if-then statement is what's called the contrapositive. And of the three, this is actually the one that's the most important. Contrapositive, what I wrote down to begin with is the contrapositive of if A, then B, is if not B, then not A. Which basically means I've done everything to that I can possibly do. I went backwards and I made both parts negative. We completely screwed that up totally. Backwards and negative. It's literally the converse of the inverse or the inverse of the converse. You do both of those things to it. Sometimes it's helpful for people to remember what's going on with this because it's the one that's big and long and you do all the possible stuff to it. Contrapositive. Again, we're going to see if you can come up with the contrapositive of a couple of things, and then we'll talk about why it is actually really the most important of them. So who knows what would be the contrapositive of if today is Thursday, then tomorrow is Friday? I suddenly switched days of the week here. So, gee, we're going to just pick somebody at random, and I'm going to see if, Mr. Greteman back there can tell me what it is. Okay. I like that a lot. Backwards and negative. If tomorrow isn't Friday, then today isn't Thursday. That's exactly right. Okay. Which, if you think about it, I think is pretty much true. Okay. And we'll let the bell do its thing, and then we'll see if we can come up with a contrapositive of if two angles of a triangle have the same measure, then two sides have the same measure. Anyone know what the contrapositive of that would be? Everyone's kind of hiding away, so I don't call on them this time. Gee. So I'm going to start with, am I going to start with sides or angles? Sides, because I got to go backwards. And what I'm probably going to say is if two sides don't have the same measure, then the two angles don't have the same measure either. Again, not the second half, then not the first half. Okay? How about if there's mass, then classes are short? What would be the contrapositive of that one? If there's mass, then classes are short. Go for it. Yeah, if the classes aren't short, then there's no mass. And if you think about that one for a second, that's actually true. If classes aren't short, there's no way it's mass day. That is definitely true, except for that one day when first hour went on forever. But that's and the last one, all squares are rectangles. Again, the original would be like if it's a square, then it's a rectangle. So the contrapositive would be if it's not a rectangle, then it's not a square. And that one actually also is true. Because if I started with like a triangle, there's no way that could possibly be a square. So it's got to be a rectangle to begin with. It actually turns out that if you have a true conditional statement, the contrapositive will always also end up being true. That's always the case. You start with a true statement and you do everything possible to screw it up, you're going to end up with a true statement. It's almost like the negatives cancel each other out is what's really kind of happening in that process. So yeah, if the conditional is true to begin with, the contrapositive will also be true. That's actually why the contrapositive is really the most important of those, because it pretty much means the same thing as the original statement, but sometimes it's easier to deal with that than it was the original. The next screen, I don't know that you necessarily need to write it down, but what we call that in logic is we say that those are logically equivalent, and you put like an equal sign with an extra bar above it to show that, but it just means, yeah, the original and the contrapositive are the same. So again, in this chapter, you do want to make sure so far that you know a conditional is like an if-then sentence. The hypothesis is the if part, the conclusion's the then part. Converse, you go backwards. Inverse, you make both halves negative. Contrapositive, you do both. And logically equivalent, that last word I tossed off just means it means the same thing, or it's true under the same conditions. That's all that is. So any questions with those that people